Welcome to Unit 2, Mod 4. The need for psychological science is the topic. Here's your vocab. So in the beginning of every flipped video, I will show you the vocab that is in this module. You might want to pause and write it down, or you might want to just move on and make sure you check it at the end to make sure you've written down all the vocab. All the vocab throughout the slides will be bolded and underlined. Sometimes I italicize keywords that aren't technically vocab, but they're very important key terms. So we're going to talk about the need for psychological science and not just relying on what we think of as common sense, because really, what is common sense? So the dictionary says that common sense is good sense and sound judgment in practical matters. But how do we get what we think is good sense? And sometimes what we think is common sense isn't actually true, or we have a reason as to why something is happening, and we think that it's clearly the cause of what we're talking about. But it's actually not. We just make assumptions. So common sense sometimes is just assumptions or guesses or things that we might call gut instincts. And those are not always true. So what we believe, even though we can come up with all these explanations as to why we are right, if we don't seek evidence and study this in a scientific way, we can't really say that it's a truth. So in psychology, we're looking at biological factors, sociocultural factors, and psychological factors, because these are influencing us all the time. And they're influencing what we think to be common sense. So just to review, psychology is the scientific study of the individual's mental processes and behaviors. So if we're going to take a scientific approach, can't be doing common sense. So here are some pitfalls of common sense. Sometimes our common sense relies on what we know as hindsight bias. Sometimes this is the I knew it all along effect. So it's a tendency after an event has already occurred to overestimate the extent to which the outcome could have been known. So if you've ever heard of a Monday morning quarterback, the game is over. You thought it was, really close throughout the whole game, but you wake up, maybe, the Patriots were behind all the way up to like the middle of the third quarter, and they make this huge comeback. And Monday morning, you're like, I knew they were going to win, right? That happens a lot. And we think that we knew it all along. Our brain tells us that we knew it all along, but we actually didn't. So hindsight bias is about thinking after we know the answer that we knew the answer all along. We think that we knew the answer all along. But when we in fact test this, we tend to be wrong. So there is also something that our common sense can betray us. It's called overconfidence, and this can relate to hindsight bias. We can be overconfident, the tendency to be more confident in our answers than we are accurate. And if you see here, we tend to sometimes underestimate an easy set of items, but we tend to be overconfident about things that are actually more difficult. You are about to take a test tomorrow in math, and you're like, oh, I understand it. It's fine. I've got this. And really, you are overconfident. You haven't tested your knowledge, and you've allowed yourself to fall into this pitfall of overconfidence. If you ask someone after they see an answer to unscrambling, so they've already seen the answers to what these three words are when you unscramble them, they estimate that it would have taken them about 10 seconds per term to figure it out. In reality, it took them 3 minutes. So people tend to be overconfident when they see the answers. So hindsight bias, when we see the answer in front of us, we're like, oh yeah, I knew that. Or, oh yeah, that's really easy. Our brain tricks us into thinking that. You can try to guess these 3 words. I will tell you the answers in class. So again, they thought 10 seconds, this will take me 10 seconds. This isn't hard at all. And this was them seeing the answers. But in reality, 3 minutes. So we have to use empiricism, which means looking for observable and measurable evidence, not our gut instinct or intuition. We as humans like to find order in random events. We, for example, see faces where they do not exist. We actually have a specific part of our brain that's just for finding faces. And so even young babies will look at images and they will seek out faces. It's actually part of our evolutionary facilitation of learning how to socialize, is to look at our parents' faces and learn from them. So if you look at this right here, this would be an example of it, right? You can see the face there probably. If I said, what's the face in a car? Like, what are the eyes? I think like a lot of people would say the headlights, right? So we can all kind of see that same thing. We often hear words in music that are not actually the correct words. And often once we hear that certain word, it's hard to unlearn the wrong lyrics and learn the correct one. So once you've seen the face, it's hard to unsee the face. It's a side profile if you can't see it. This is his hair. This is the nose. So if you think about a coin flip, our brains like to think that if it's been heads the last 6 times, we might think, oh, it's on a streak, it's going to be heads again. Or our brains might tell us, oh, it's been heads the last 6 times, it's got to be tails this time, it's got to be, right? Like it somehow makes sense that there's a greater chance of it being heads or being tails based on previous coin flips, when in reality, it's going to be 50% chance every single time. So we have to use the scientific method. We have to create a hypothesis and we have to test it. And we have to look at the evidence and continue on in that scientific method. So how do we find real truth and avoid all of these pitfalls of common sense? First, we have to apply critical thinking skills, which means to examine assumptions that we've made, question them, assess the sources that they come from, discern what are the hidden meanings behind some of these things, confirm that our evidence is accurate, and look at our conclusions carefully. How do we do all this? We need to keep a scientific attitude, to remain curious. These 3 words are important: curious, skeptical, and humble. So the curious, to ask questions. So instead of making an assumption and saying that it's common sense or hindsight bias, we should ask a question and even question our own assumptions, especially our own assumptions. We should be skeptical of people giving us very confident answers, even ourselves. We might fall into overconfidence. We should be skeptical. We should question and not necessarily trust. We should look at sources. We should look at motives and think about what is playing a role here. And then lastly, we have to be humble. If we make a hypothesis and we are wrong, we shouldn't work to continue to just try to prove ourselves right. We should try to be seeking the truth. And so to always seek the truth, sometimes you're going to be wrong. There's a saying in psychology and in science that the rat is always right. If the rat does a certain thing and your hypothesis said the opposite, your hypothesis is wrong and the rat is always right. So our takeaways, remember that we can trust our gut with our feelings, our emotions, but not with what is truth. We might fall into hindsight bias and overconfidence. We might perceive order in random events if we do not use a scientific attitude. This leads us to overestimate those gut instincts, or what we call common sense. And so we must remain curious, skeptical, and humble. That wraps up Mod 4, and I will see you in class.